Hello guys, my name is John Michael E. Reyes and I'm from Batangas State University, Alangilan Campus, and I'm currently a second year BSIT student. And today we are gonna tackle or answer an activity in the chapter 5 Ethernet in the 5.2.1.6 activity, the switch it. Please bear with my voice because I'm pretty sick right now. And as you can see, there are the Ethernet frame, the MAC table, the switch, and the devices, the hubs, and other two connected devices. And there are questions, and that should be answered. So let's proceed. First, let's check the frame. We all know that the Ethernet frame is somewhat the preamble, destination MAC address, source MAC, length, data, and the frame. But let's recall the preamble. The preamble is somewhat separated into two, the preamble and the SFD. The preamble is a 7-byte and the SFD is also called a start of frame or a 1-byte. Fields are used for synchronization between the sending and receiving of devices. It is somewhat synchronized if you're gonna send a specific frame to the other device, or you will gonna receive a frame from the other devices. These first 8 bytes of the frame are used to get the attention of the receiving nodes. Especially the first few bytes tell the receiver to get ready to receive a new frame. It is somewhat the checker or the one that gives signal if the sender or the receiver will receive or send some frame. Then let's go to the destination MAC. The destination MAC address field is a 6-byte field, is the identifier for the intended recipient. It is somewhat the destination MAC is somewhat the specific receiver or where the source MAC will send the frame. Then as you will recall, this address is used by a layer 2 to assist devices in determining if a frame is addressed to them, because if somewhat destination MAC is not in there, the frame would be lost or somewhat go to the other ports that are not intended to be sent in that port. The address in the frame is compared to the MAC address in the devices. If there is a match, the device accepts the frame can be a unicast, multicast, or broadcast address. If the IP or other things are matched, the device will somewhat agree or accept the frame, but if it doesn't, it just discards it. Then let's go to the source MAC. The source MAC address field is also a 6-byte field, identifies the frame's originating NIC or interface. It is somewhat the specific sender or specific device that who will gonna send a frame. It must be a unicast address. Then header type or length type, header type field. This is a 2-byte field, identifies the upper layer protocol encapsulated in the Ethernet frame, and then common values are in hexadecimal. And for the IPv4 or Internet Protocol version 4 is 0x800. Then for the Internet Protocol version 6 or IPv6 is 0x86DD. Then for the ARP or are 0x806. Then let's go to the encapsulated data or the data field. The data field is somewhat a 46 to 1500 bytes. Contains the encapsulated data from a higher layer, which is generic layer 3 PDU, or more commonly an IPv4 packet or Internet Protocol version 4 packet. All frame must be at least 64-byte long. If a small packet is encapsulated, additional bits called a pad used to increase the size of the frame to this minimum size. Then, the frame check sequence or the end of the frame. The frame check sequence field is somewhat in the trailer with an error detection. The frame check sequence or FCS is a field is 4 bytes is used to detect errors in a frame. That's why I said it is somewhat in the trailer, and the trailer have the error detection frame. Then it is used to cyclic redundancy check or the CRC. Then the sending device includes the result of CRC in the FCS fields of frame. The receiving devices receives the frame and generates a CRC to look for errors. If the calculation match, no error occur. If somewhat the frame is in the right size, no errors will occur. But if the calculation that not match are in indication that the data has changed, therefore the frame will be dropped or discarded. A change in the data could be a result of disruption of the electrical signals that represent the bits. Then we are done with the Ethernet frame. Then let's go to the MAC table. The MAC table is somewhat connected to this switch. As you can see, the OA or the port FA1 and FA3 or the port FA3 or the OB and the port FA9 or the OE is already registered in the MAC table. And as you can see, the source MAC, the OC in the FA5 and the destination MAC OD in the FA7 port is not registered on the MAC table. As my conclusion in this is somewhat OA, OB, and OE already transfer some field, send or receive some field with each other, or it already have transaction with each other. That's why in the MAC table they are already listed or added in this table. Then let's try to answer it. As you can see, OC is the source MAC. That's why you won't check the FA5. You won't check this because it is already the source. Then the destination MAC. The destination MAC is the OD, which is in the FA7 port. So we will click the FA7 port. And after that, as you can see, these two are not in the MAC address. That's why it will be flooded. Even it is a unicast frame, but still it will be flooded in all ports because the MAC table they are not in the MAC table and they are not already added in the MAC table. Then we will check the OA or in the FA1 port because they are connected with it is connected with the switch, and the FA3, the end device in the FA3 or the OB. Then the FA7, we won't check the FA5 because as I've said, it is the source or the origination of the frame. Then the FA9, because as you can see the O is in there, that's why we will gonna check FA9. Then sorry for that. Then in the question 2, which the switch forward the frame, which statement is true, and in this answer the answer will be 2 because as we can see the destination and the source MAC is not added in this MAC table. We will add it. Switch adds the source MAC address to the table, and as I've said earlier, the frame is a unicast frame and it will be flooded in all ports. And let's check. As you can see, I've answered successfully in all the questions based on the information in the frame and MAC table. Analyzation is somewhat very specific or very helpful in this, because if you analyze carefully, you can just click and get the answer easily. That's why analyzing in some ways is somewhat very helpful. That's all. Thank you for today and have a good night.